My dear students, this is your professor, Dr. Syed. You are welcome on the online learning platform. Today I am going to teach you about the gating systems in the casting process. Introduction. The mold is used for producing a casting. Molten metal is conveyed into the mold cavity by using gating systems. In casting process, gating system plays an important role to produce a high quality castings. A poor designed gating system may result in casting defects. A gating system controls mold filling process. The main function of gating system is to lead molten metal from ladle to the casting cavity, ensuring smooth way, uniform and complete filling. The elements of gating system. You are seeing here the diagram of gating system. This is basically used in the castings. In the gating system, you can see a pouring cup. Under this, you can see a sprue. Then you can see a sprue well. Then you can see a cross gate or what you call a runner. Then you can see in gate or pouring cup. It is the funnel shaped opening made at the top of the mold. The main purpose of this pouring basin is to direct the flow of molten metal from ladle to the sprue. Then what is sprue? It is a vertical passage connects the pouring basin to the runner or ingate. It is generally made tapered downward to avoid aspiration of air. The cross section of the sprue may be square, rectangular or circular. Then what's a sprue well? It is located at the base of the sprue. It arrests the free fall of molten metal through the sprue and turns it by a right angle towards the runner. Then what's a runner? It's a long horizontal channel which carries molten metal and distributes it to the ingates. It will ensure proper supply of molten metal to the cavity so that proper filling of the cavity takes place. Then gates. These are the small channels connected the mold cavity and the runner. The gates used may vary in number, depends on size of the casting. The functions of gating system. A good gating system should help easy and complete filling of the mold cavity. It should fill the mold cavity with molten metal with at least amount of turbulence. It should prevent mold erosion. It should establish proper temperature gradient in the casting. It should promote a directional solidification. It should regulate the rate of flow of metal into the mold cavity. The defects occurring due to the improper design of gating system. If your gating system is not perfect, you are going to get the different types of defects. So what are the defects? Oxidation of metal, cold shuts, mold erosion, shrinkages, porosity, misruns, and penetration of liquid metal into mold walls. The types of gates. Depending upon the orientation of the parting plane, one is horizontal gating system, two vertical gating system. And again, depending upon the portion of in-gates, there is horizontal gating system, one is top gating system, two bottom gating system, three parting line gating. Now you are seeing the different types of gates. Starting from left side, A, this is a top gating system. The gating system is on the top of the mold cavity. B, bottom gating system. The gate is at the bottom of the mold cavity. C, parting line gating. The gating system is between the mold cavity. Pouring time. The pouring time is most important. The pouring rate is nothing but the time taken for filling the mold cavity by a known quantity of metal. That is, pouring time can be used as an index to determine the pouring rate. When molten metal is being poured into the mold at a very fast rate, mold erosion, rough surfaces, excessive shrinkage may take place. When the pouring rate is very slow, the complete filling of the mold is not assured and may result in excessive drop in the molten metal temperature. This results in casting defects such as cold shuts, misruns, etc. In order to avoid this, it is necessary to arrive at the correct rate of pouring of metal into the mold cavity. The type of metal, size, and shape of the casting decides the pouring rate. Gating ratio. The gating ratio refers to the relation between the area of the choke to total area of runner, total area of gates. Mathematically, it can be written as AC AR AG. AC is for choke, AR is for runner, AG is for in-gates. The gating system completely controls the molten metal flow. Gating systems can be classified as pressurized system and unpressurized system. Gating ratio depends on the nature of the molten metal. The pressurized system is used for reactive metals like magnesium alloys, etc. The unpressurized gating system is used for normal metals such as brass, steel, aluminum, alloy, etc. A gating ratio such as 1:2:1 or 1:0.75:05 refers to pressurized system, whereas the gating ratio